Hi, thanks for joining me. I'm Marielle Biller from ClearML, and I want to talk to you about build over buy, the golden ratio, and how Theator scaled up its continuous training framework. Allegro AI is a company founded in 2016 by veterans from Google, the Israeli Defense Forces, and computer vision PhDs. About 47 patents and 23 publications. We launched Allegro Trains, an open source MLOps platform used by more than 1,000 organizations in over 50 countries. And we just recently rebranded as ClearML. We partnered up with NVIDIA, Intel, IBM, NetApp, Arrow, and HPE. Let's do this obligatory on the product slide. ClearML is an open source MLOps platform leaning towards lean stack. So one product that gives you experiment management, workload orchestration, data management, and even more coming. Really focusing on the bottom-up design, which means you start from integrating on the code, and then logging, orchestration, and workflow versioning on top of it, then dataset monitor management, and remote session work and debug. And it's used by more than 1,000 organizations. Here are some names, and let's begin. So today we're going to talk about build versus buy in the context of MLOps, and especially deep learning in a startup. The startup is Theator, Surgical Intelligence, and we're going to hear from the CTO, Dr. Nasselman, soon. Then we'll define the challenge of scaling deep learning inside a closed loop type of production, go over some challenges and advanced features, and project them onto the build or buy dilemma. And we finish off with some lesson learned and summarize. So, build versus buy. It's a story, it's older than software itself. I'm assuming, maybe guessing that 50% of you at least are contemplating build versus buy at this very moment. And when I'm saying buy, I'm not necessarily saying, speaking about money, it's also buying into some kind of open source. And it's really a question of whether you want something now, or maybe you want to wait and get it later, or if you want something simple or something that scales better but is maybe more intricate. And there's a lot of factors to consider. There's a lot of company culture factors and even geographical factors. But really, I want to focus on to the technical depth aspect of this, right? You just have to decide what kind of technical debt you're getting into and when you want to pay it off. And with infrastructures, sometimes you have to go with the buy route. Now, if you want to integrate a deep learning component inside your product, then your options are a little bit more limited. There are variances in the use cases that are very huge, so there's not a one-size-fits-all stuff that you can buy. Mostly you have time constraints on this integration project that force you to maybe favor buy over build. And even if you go over buy, there's much research needed to integrate with your own use case. And you're working in a space that there are a few best practices already known. So you can make a lot of mistakes that other people have already made and not know about it. Especially if you want to do any buy over infrastructure, you will find a lot of very young products with no history. So already you have some kind of a switch between build and buy, right? You want to buy as much as you can, but sometimes you're not able to. And this even gets worse when you go to a deep learning core product. What do I mean by core product? It's something that's deep learning is ingrained in the use case that you're trying to sell. So obviously, right now, as I said, no one size fits all. Then off the shelf for scaling is not relevant yet. So that's definitely a build. And infrastructure is going to be tailored to your own use case. So it's, again, definitely a build. What's definitely an option for buy? That's data management, because data management is nothing new. And what I think is also something you should consider for buy is something that will help you to emphasize transitions from research to production in an easy or maybe productive manner. can you buy such a thing? I think that yes, but history will tell us, right? So, speaking of history, in 2015, there was a paper in Europe, basically a part of a triad of papers from 2014 to 2016. So, and this is the middle one, which I like most. It's called Hidden Technical Debt in Machine Learning Systems, made by a lot of good people from Google, and based on their experience with deploying machine learning in production. And what they offer in one of the slides is an image that you might have seen already because it's everywhere. And it's a model for if your code that you need to deploy is here, then around it there's an infrastructure envelope of many, many different things that needs to be either built or bought and integrated together. And this infrastructure envelope nowadays is called MLOps. But I'm not saying that this is the infrastructure that you need. You might need something different, but this is the basic image as learned from experience in Google. And what I want to take us now is to a world where this is probably not the main issue. The main issue is taking code and actually moving it to production as fast as possible. And it's the startup world. And I want to invite over my good friend and CTO and co-founder of Theator to talk about their company, which we will use in the next part of this presentation.
Thank you, Ariel, and thank you for having me here. Hello, everyone. My name is Dotan Asselman. I'm the co-founder and CTO of Theator. And I want to introduce you to our world. So each year, there are tens of millions of surgical procedures done in a minimally invasive manner. This means using some kind of visual guidance. But when you are looking at this world, and as opposed to what you see in sports or any other areas that elite athletes or NBA players are measuring any movement of the players in order to measure themselves better, analyze it, and improve, this is something that not exists in the world of surgery. And this was the basis of what sparked us to build Theater, basically. And we introduced to this world a field that we defined it as, we coined it surgical intelligence. We basically leverage computer vision and machine learning to analyze any key moment in surgery, connect what happened in surgery to outcome measurements and understand best practices in order to improve surgical care, to help surgeons to improve their craft in a continuous manner. We started the company about 2 years ago, and we started very small. It was basically a small research project with 80 publicly available videos that we found of one surgical procedure, and that was very easy to manage. We are now in a position that our datasets are bigger than 15,000 surgical procedures. We are getting hundreds of new procedures every day. And our research team got to a situation that we are investing way too much time on maintaining our dataset and our incoming videos, to retraining them, to generate new data versions and train existing models instead of working on new features, new capabilities, and building new algorithms. And this was the point that we understood that we had to automate. And Ariel here will show the use case, or the use cases that we decided to work together with ClearML and automate our entire process from what we call nightly build automation of generating new version and retraining, up to deployment to the production environment with no research team in the process at all.
Great, thanks, Dotan. Dotan will be available for the Q&A in the end. Let us continue. So, let me just expand a little bit so we know what this challenge of scaling and automation actually means. So, in terms of research, you've heard these procedures and videos. Each type of surgery needs a new approach. So it means that there are many intertwined research projects going on at the same time. And the end results are analytics for doctors. And these are based on multiple models. So it means that if there's a certain model within the process that has an aberration or the performance tanks, it means that everything breaks down. So you need stringent control over the entire process. Then eventually the product gives decisions. So it has to scale up to real-time inference on surgical videos at the hospital where the surgery is being performed. In terms of data, you heard thousands of footages coming in, and that created this whole scaling issue. And in order to take care of all of the above, you need a very tight continuous integration, deployment, training, lots of continuouses. And what they needed is a single control plane. And that's what they did. Eventually, if you look at the production diagram here, in terms of schematics, it doesn't look that different than what you'd expect in a deployment in an edge device. There's data that's coming in, there's training, and then there's production. But training here is multiple models at the same time, and production means inference on some kind of input video, either from the workstation or from the actual surgery, transitioning into an actual data input, inference, and then the results in terms of decisions flowing back into the doctor's workstation. And then there's the closed loop. Okay, they call it the feedback loop. For us, we can expand it, call it data engineering. That takes care of the data intake, the tagging, cleaning, versioning, and storage. So in each of these parts, there's work to do to automate, right? So let's delve in and look at where they chose to build and where they chose to buy, and see if we can learn something from it. Okay. So data, I told you that data was a first choice for buying, and that's actually what Theator did. So, and that's why we started working with them. The ClearML enterprise solution gave out of the box the abilities that they needed for versioning, for data sets that can be queried. And, if you want to slice up a lot of data on the fly for some research, then you also want to mix and match these data sets on the fly without making any file operations. And then you get some data set that might be imbalanced in terms of concepts, and you need to balance them on the fly, a lot of on the fly. And then, again, everything needs to be optimized. And up to the compute node, everything is buy. But when you want to do fast GPU loading, and your videos are, in terms of length, somewhat long, right? They needed to build something over the normal PyTorch serving. And here's a quote. We won't get into it. Now, on the other hand, there's research, right? Research, as I said, there's ongoing and iterative, and there's new projects all the time. And all the code should be built, right? Because that's your unique use case. But again, you don't build from scratch. You use a framework, and they use PyTorch. And experiment management and training orchestration, that's the open source offering of ClearML. And now the interesting thing comes when you want to try and automate beyond the orchestration, and we'll see a diagram soon. The model training itself is using experiments that's been done and proved to work as templates, and you can build off over them without changing code. So that's something that was really leveraged in Theator, and they built something they call the pipeline master controller. In their own words, it's something that enables you to orchestrate an unlimited number of concurrent pipelines spread across various datasets and machines, on-prem or in the cloud. What I call it is DSL. Okay, it's a language that maps onto the infrastructure provided by the ClearML product. And is written in a language that the researchers know and understand. So they're able to generate very intricate training pipelines using tasks and experiments that already have proven to work, in a few simple terms. And that's the way I actually like it. I want the YAML files and the configurations to be written automatically, if any, and only a very small amount that needs to be written by the researcher itself. And the diagram is this. So you choose the data, and then you have this controller task that you write in your own DSL, and it maps onto creating the config for the models, spinning up the train tasks, defining the pipeline or the directly acyclic graph. In Theator's case, it has to be very intricate because one model may be training and producing a model that's used over the same data to produce more features, and then these features are being used for training for the second model. And once this kind of complex training is done, the machine, actually, okay, so this is the diagram, and everything is put up into a machine that's spun up automatically, and then the training is being done. And once that training is done, you need to spin the machine down, and all the models are automatically saved in the data hub. Now, the continuous training aspect, which really makes the production challenge unique or automation friendly, is the following. So let's break it down. Okay, for the pipeline itself, the nice thing is that you're able to use the same code that you use in research. Okay, so it essentially means that if you have an iteration over your research, you found something that works, the amount of code that you need to write to push that onto production is a 0. And in order to do it, you have to train, say, machines, for example, in research and production, and those are NVIDIA's V100s. The video inference pipeline is definitely a build. As I said, in the Theator's case, they built it over Javier GXs for the edge device, T4 for cloud inference, and everything is using DeepStream 5. Now, specifically the feedback loop, okay? So the data intake is definitely continuous integration. And that's something that you shouldn't build. You can buy it. It's not that different. If your use case, I mean, in terms of use cases, it's not that different from one to another. The other things are definitely a build, right? Cleaning the data and other data engineering aspects. Tagging, manual and auto, if you're doing active learning, it's something you probably should write on your own. Retrain triggers, for example, when do you do another training iteration and serve to production again? Maybe it's because monitoring says something, maybe it's because you've doubled the amount of data that you have. All of that you should decide on your own. In this case, it can ride on top of your infrastructure already. The same with regression testing or continuous deployment. So I hope we dive deep enough. You can ask more questions about it in the Q&A part. But now let's move on to the lessons learned. So again, hoping that you realize that I'm leading kind of a classical paradigm here, that software development, technical debt management is really not that different if you're doing deep learning. You just avoid reinventing the wheel at all costs. It's just a little bit more difficult because you have less history in this case. And then you build on top of comprehensive, better tested things that you buy. I always say that, WhatsApp, when they were first bought, they were serving, I think, 450 million users, and they were doing that with 35 engineers. Well, you can't do it if you build your own. You build over a very thoroughly tested stack. And in the future we will have it for all deep learning products, but I mean, you just right now you need to use whatever you can. Now, specifically on deep learning, as Dotan said, if 80% of the data is the work, if data is 80% of the work, sorry, then you automate it. There are no ways around it. But again, there's other aspects. For example, moving from research to production requires this flexibility of infrastructure, meaning that if you change something, that it's very straightforward to push it to production. And also this master controller that they built really allows you to think of iterations in your research and improvements and test them readily. And when they seem that they work, you can push them to production. All of this was based on the fact that they mapped their own experiments onto the basic unit of the experiment tracking platform inside ClearML. And I think that's a key lesson here, that you isolate some kind of atomic unit and you map on top of it, so you're able to build from the bottom up. So you don't have to try and rewrite codes that work into something that might work with the MLOps solution that you try. The vice versa. You don't change anything that works. Okay, so to summarize, the build over buy is always going to be a ratio, okay? Because you never be able to buy all that you want. And the ratio is use case specific. In terms of deep learning, it's evolving. Again, with the statement that buying also means buying into open source, because that has a cost in their technical debt management. And then also that classical software paradigms work. In this case, what I favor is the stable and lean stack. Now, for now, you also have to build your own MLOps. And again, with the bottom-up approach, as I recommend, not top-down. And that luckily you can isolate these useful abstractions or atomic units that I mentioned. That means that you don't have to start from scratch. You can build over something that somebody else tested and vetted. Now, speaking of this somebody, that's why we actually built ClearML and released it as open source. And so I recommend that you follow us if you want to learn more about this. And lastly, before thanking you for listening, I want to invite you to a workshop, this very own TWiML that I'm giving, I think it's next week, on how to really start off with MLOps with 2 lines of code or less. Okay, so thanks for listening on behalf of ClearML and Theator, and I'm now ready for questions.
All righty. Thanks, Ariel. Thanks, Dotan. Let's get you up and let's dive into questions. You were actually just in the chat answering a question around how far down into the infrastructure stack do you go, and do you think about build and buy differently there? You did quickly address that, but maybe elaborate on that. It sounds like you're doing some stuff with Kubernetes at Theator, Dotan.
Yeah, that's right. So hello everyone, and yeah, in general, you have the application layer that we need to be able, based on the templates that we got from ClearML, to run this nightly. We call it nightly build for us. So like just run the process each night that generates the new data versions and generates all of the automation for the retraining. This is all pushed as a Kubernetes jobs, and each job have the ClearML agent, and then we have just like the very standard cluster autoscaler on Kubernetes that just picks up all of the up level on the utilization and just open new GPU machines.
Awesome. Ariel, you mostly addressed kind of this build versus buy question from, what I kind of think of as a day zero perspective. In the keynote earlier with Faisal from Netflix, we talked about this need to kind of constantly evaluate build versus buy, because even if you have a solution in place, you have to maintain it. What's available on the market changes, the needs of your constituents change. Is that something that you've seen a lot of folks transitioning from things that they've already built to something that they buy? And is there a different way you need to think about that?
Absolutely. That's an excellent question. So let me take it from the top. First of all, this kind of, I've built something, but I realized that it doesn't scale and I want to go, I need to employ something else to scale up. And that's something which you see in software a lot. I actually saw it for the first time doing HPC, writing Fortran code and chemistry. And the tendency for even the most battle-hardened veterans of code is to just say, oh, let's throw everything and rewrite, right? And that's not what businesses do. They do what I like to call, I think it's strangling vine methodology, where you wrap stuff that you have with tests, right? So you can call them unit tests, even though it's data, and then you start to substitute stuff that you can scale up with. And actually, as I said in the presentation, we're supporting this bottom-up methodology, and it actually works for you if you are you already have something in-house and you want to integrate, because integration is supposed to be a breeze with ClearML. And actually, I think no other MLOps tool in your stack should be something that's hard to integrate with, because basically this is stuff that you might, as you said, you want to maybe throw away and take something new as the paradigms and methodologies around you evolve. You don't want to get stuck in the past with something that you just feel like you bought into and you have some sunk costs onto it. But that's really to face off the first part of the question. I think big organizations like Netflix can afford to actually build everything, right? And they actually build it twice. They build it once, they scrap it, and then they build the one that they actually use because they can afford it. Most other businesses can't do that. And you have to have the correct balance between build and buy from day one. And that's why you look at startups to see how they do it, and you copy it. And I think that's also true because the theories change, right? Deep learning is just evolving. Tomorrow you're going to train completely different to gain twice as much accuracy with twice as less data. And so would you need to write all your code and your infrastructure to support this, or just write all your code again?
Right. Dotan, what's missing in the infrastructure that you've built, and what are you kind of looking for solutions to, or for the industry to evolve to provide you to support the company?
Okay, so I think a lot, but I think the main thing that we are now pursuing is to right-sizing the resources to the specific experiments. So we are on the cost reduction journey, and we want to be able to be way more efficient than we are right now, and just thinking about a less than naive way to find the right resources at the right time for the specific experiment. This is something that we are also in pursuit of right now.
Awesome. And Ariel, in 30 seconds, what are you going to cover on the in the workshop, which is next week, Tuesday at 1 p.m. Pacific?
Okay, so we built ClearML to be really easy to integrate with, but it's feature packed. Okay, you can't just dive into it on day one and know everything that you need to be a master. But if you take my workshop, you can. After I think 30 minutes, you'll be able to ramp up entire MLOps using ClearML with a breeze. So I'm hoping to see all of you there.
Awesome. Ariel, Dotan, thanks so much for joining us. Great presentation.